a derivatives trading corporation is going to use the R for portfolio optimization. We are going to use R in order to build portfolios that will generate an efficient portfolio with high risk-adjusted returns. The goal is to open up a fund, a commingled fund, that will bring in roughly $2 billion at least a 1% fee. So this is an active portfolio. We're using R because it can create an efficient frontier. The efficient frontier is created using different theories, such as portfolio variance, mean variance, and the Lagrange theorem. So we'll talk about those very briefly. Next in the discussion, we are going to show you how to create a time series using 4 different securities. These securities will be part of the efficient portfolio that we're working to build. And then lastly, we will show you how R can run a Monte Carlo simulation that will generate the efficient frontier. It will not only show you the portfolios along the efficient frontier, but also the portfolios that lie below it. So as a brief overview, portfolio variance is used to measure how the returns of all the components within a portfolio change. The portfolio must contain more than one asset, and so in this case we will review the portfolio with 4 different securities. The goal is to have less risk through diversification. The formula that you see here is something that R uses in order to help explain how the portfolio variance looks. And when you use that formula, it produces the above graph. The most important thing about this formula that it illustrates is not only the covariance, but also the standard deviations. And in this case, we're just looking at 2 different securities within the portfolio, so X and Y. I'm going to now hand this over to Mingji to discuss the mean variance model application within R.
The mean variance model helps us to better understand and formulate the portfolio. And first of all, we will define the mean variance model by definition of asset and portfolio. If we use X to represent different kind of assets, and the W will be the weights of each asset. And the process of portfolio optimization will be finding the optimal weights for each asset and to achieve 2 goals. The first goal is to reach varying the minimal risk for a given level of expected return. Or we can say we will generate the highest return at a different level of risk. If we put the assets and their weights into a formula, and the 5 problems will help us to achieve our goals. And let me explain each of those five problems. The first one will be find the portfolio with minimal risk, and the second one is maximize the expected return on a given level of variance. And the third one is to find a portfolio with minimal variance on a desired level of expected return. And the fourth problem is to maximize a simple utility function, where the sigma represents a coefficient of risk tolerance. And the fifth is we use Y to represent the n+1 assets which we don't want to buy or we don't want to hold, but want to replicate it. And we can solve those five equations using Lagrange theorem. And which is find the right coefficient to make the partial derivative of the function equals 1, but equals 0. And here is the approach we used, the commands we use in RStudio. And if you plot all the maximal returns on each level of risk, we can get a group of outcomes, which is the efficient frontier. And so how can the portfolio optimization help us in real-world investment? I will say that it gives us a sense of finding the optimal weights. However, because our model is based on historical data, so this portfolio only reflects the past informations. But in real world, our financial market is semi-strong form efficient, so the stock price reflects all the public information. We cannot reach a efficient frontier solely on this model, but we can add our expectation of the stock prices into this model, so that we can reach a optimal portfolio structure based on our prediction. Thank you.
I'll be talking about time series. So first of all, how to transform data into time series. Our language provides a lot of packages which is very useful for making various type of analysis, and it doesn't require a lot of coding. So one of the package which I'll be talking about is F portfolio, and it helps us in it applies time series, helps us in applying time series. So here we are going to do the analysis of 5 IT products, tech companies product. First of all, the command which we'll use will basically, first of all, we'll download the time series package. Next slide. Here, in order to graph it, we first need to calculate the returns, and basically the returns can be calculated by dividing the element which is prior to the prior one and computing the log. In order to compute the log, these two are the command, we can use either of them. And now, since we need to plot it, so this is the instruction for the plotting of the 5 stock. And as you can see, the returns of the 5 stock, as per my understanding, our language can be very helpful in order to understand what all products can be included, what all stocks can be included in a portfolio. So we can combine a highly volatile stock with a company which is less volatile and get an optimal portfolio. Now Kiran will be continuing. Kiran will be talking about portfolio frontier.
Thank you, Hema. So I'll be talking about portfolio frontier, which is also known as efficient frontier, and which doesn't require much coding. The efficient frontier is the set of optimal portfolios that offer the highest expected returns for a defined level of risk, or the lowest risk for a given level of expected returns. And to draw a portfolio frontier chart, the following commands are needed. And first of all, we need to install F portfolio package, and in order to plot the graph, enter the second command. And to make a plot selection, we can add minimum risk portfolio. We can also add tendency portfolio or equal weights portfolio, and 2 asset frontier also. And talking about short sale restrictions, are the only one possible constraints, and short sale is usually regulated type of market transaction. It involves selling assets that are borrowed in the expectations of a fall in the asset price. So if we look at the commands, so here we have a special portfolio spec with the function of solve or short exact that optimize an unlimited short selling portfolio, and the results are shown by the frontier plot with orange colored circles, and Monte Carlo similarity points are also added to the graph besides a grid in the background. And here is the graph. On the x-axis it shows target risk, and on the y-axis it shows target returns. And the orange colored circles are the efficient frontier, and the portfolio lies within the efficient frontier optimal portfolios. And now I would like to call Amanda to conclude the presentation.
Thank you. So we have just demonstrated how R can create the efficient frontier and also run the Monte Carlo simulation in order to build the efficient portfolio, as well as show the portfolios that lie under it. In doing some research, we understand that R is optimal for using Excel because it's efficient in graphing and it's much simpler. The commands to create the data and the graphs are easily entered into the program, whereas Excel is much more challenging program to try to use to not only build, well, most importantly, build